This is leap interim practice. This is the part with calculator. So if you got your calculator, pull it out and let's work on it. In the triangle shown below, find the value for x to the nearest 10th. Well, if you notice, what we're looking at is a right triangle. Are we looking for angles or are we looking for side lengths? We're looking for a side length. If you're looking for a side length of a right triangle, you use Pythagorean theorem. A squared plus b squared is equal to c squared. And your formula sheet will show you a right triangle, and it shows you that the two legs are A and B, and the side that's a hypotenuse across the right angle is the C. And it will show you the formula for Pythagorean theorem. A squared plus b squared is equal to c squared. All of this will be on your formula sheet. Now, all we have to do at this point is solve it. The first thing that you always do is find out where the C is. See how it's across the right angle, and your formula sheet will show you that it's across the right angle. So there it is, right there across the right angle. There's your C. As far as A and B, it does not matter which one is which. C is the only one that does matter. Now let's plug it into Pythagorean theorem. In this case, we're going to substitute x in place of A. We're going to substitute 8 in place of B. And we're going to substitute 14 in place of C. Okay, we bring down our x squared. 8 squared, if you put that in your calculator, that's 8 times 8, that's 64. 14 squared, if you put that in your calculator, that's 14 by 14. Okay, or you can say 14 squared, either way works. And you get 196. Okay, now we're trying to find x, the length of this side. So let's keep going. At this point, I've got to cross the equal sign to be able to solve for my x. 64 is added to this side. The opposite of adding 64 to cross the equal sign would be to subtract 64. And when you're crossing an equal sign, you do the same thing on each side. Keep everything fair. Whatever you do on one side, you do on the other. 64 plus negative 64 is 0. That's x squared is equal to 196 minus 64. Make sure that you use your calculator when you do that calculation because you don't want to get it wrong. That would be 132. X squared is equal to 132. I'm not looking for x squared, I'm looking for x. The opposite of squaring a number is to take the square root of it. So in your calculator, you're going to take the square root of 132 because what you do to one side of the equal sign, you do to the other. Now remember, in your calculator, if you've got a TI-30X, on your left-hand side, there's a light blue button at the upper left corner that says second. Press second. On that same row, let's say the 1, 2, 3, 4, 5, 6 thing down, there's an x squared. Above it is the square root. You press that square root, 132 equals. You should have 11.5. So your answer should be 11 point, well actually it says 11.489, but let's read up here to see what it actually asks us. It's asked for the nearest tenth, right? Nearest tenth means we need one decimal place. To decide what that one decimal place should be, you look to the value behind it. 5 or more, raise the score. 4 or less, let it rest. This is 5 or more. This is 8. So I'm going to bring this 4 up to 5. It would be 11.5. X is equal to 11.5. Now let's see if that makes sense. If I've got a right triangle, the hypotenuse, the side that's across in the right angle, is always the longest side. You've got 11.5 and 8 for the shorter sides, and this is 14, so that could make sense. Okay? Now let's look at number 2. What is the length of the missing side of this triangle? Well, notice this is also a right triangle. And I'm looking for a side length. If I have a right triangle and I'm looking for a side length, I can use Pythagorean theorem. A squared plus b squared is equal to c squared. Now remember, your formula sheet is going to show you a right triangle. It's going to show you the right angle, the little box. It will show you that C is across from this right angle. It will show you that A and B are the two legs. It will show you the formula, A squared plus B squared is equal to C squared. So see, your C, which you need to find first, is always across from your right angle. And if you use your formula sheet, it shows you that. So let's find our C. Here's our right angle. This side's going to be our C. It does not matter then which one is A or B. Let's just substitute these in. 13 squared plus 9 squared is equal to C squared. I'm looking for C, the hypotenuse, across from the right angle. That's going to be my longest side. Okay. Now, in your calculator, 13 squared, that means 13 times 13. So that is 169. Okay, 9 squared, that's 9 times 9. Use your calculator if you want to. That's 81 is equal to C squared. Now, we need to solve for C squared. Notice, we can collect like terms here before we cross the equal sign. So we want to do everything we can to simplify an expression before we cross the equal sign. That would be 169 plus 81. 169 plus 81 would give you 250. Okay, so 250 is equal to C squared. It's obvious that this side's not 250. That's much bigger than these two. We're looking for C, not C squared. The opposite of squaring something, to get this as just C, I would take the square root. And what I do to one side of an equal sign, I always do to the other. The square root of C squared is C. See, that's what we're looking for. Now let's find the square root of 250. In your calculator, on the left-hand side, the light blue button, if you have a TI-30X. Second, the button that says X squared, right above it is square root. Press that one. 250 equals, and you should get 15.811. Okay? Let's see. That would be 15.811. It asked me for which one of these it is. 15.81. Okay? It only did it to the nearest hundredth, right? Okay. Let's look at the next one. Find the slant height of the cone. Okay. Slant height, and they would mark this for you. The slant height, when you've got a cone, is the height of the cone that's slanted. It's the part you would walk up if you were trying to walk up to the top, okay? Instead of taking the elevator up. If you were on stairs, you could walk up the side. This is the height. This is the actual height, okay? So slant height, we are looking for this side right here, okay? Now, let's notice we have a right triangle here, don't we? Okay, because here's your right angle, right? Let's figure out our measurements. If we've got a right triangle and we're looking for this side right here, called the slant height, call it S. On this right triangle, I've got 12 here. That's the height of the cone. This whole thing here, the diameter of this circle is 16. What would be half the length of that, this radius? 16 divided by 2 would give me 8, right? So this part is 8. So now I'm looking for this side, and I can use Pythagorean Theorem because I'm looking for a side of a right triangle. Our formula sheet on Pythagorean Theorem shows you that you've got C, A, and B. C is across from the right angle, and Pythagorean Theorem can be used to find any side in a right triangle using A squared plus B squared is equal to C squared, where C is the hypotenuse across from the right angle. Okay, so let's put our formula here. A squared plus B squared is equal to C squared, because we're looking for a side in a right triangle, aren't we? We can make a right triangle out of this, and we're looking for this side right here. First, we've defined the C. It's across from the right angle. That C would be this slant height, wouldn't it? Okay. So I'm going to put the S in there. A and B, it doesn't matter. The C, it does. So I'll substitute A in as 12. For B, I will substitute in 8. Okay? Now, let's take care of this. What's 12 squared? 12 times 12, you can put it in your calculator, it's 144. How about 8 squared? That's 8 times 8, which would be 64. That gives you your slant height squared. Okay? Now, before I cross that equal sign, let's collect our like terms. We can add 144 plus 64, and we get 208. 208. 208 is equal to the slant height squared. Okay? I'm not looking for the slant height squared, am I? I'm looking for just the slant height. The opposite of squaring something is to take the square root. That would give me S, but what I do to one side of the equal sign, I have to do to the other. So I need to take the square root of 208. In your calculator, the upper left-hand button, light blue, second. The x squared button right above it's the square root. Square root 208 equal. You should get 14.422. Okay, your slant height, 14.422. Which one do I have here? Yep, 14.4, because it said rounded to the nearest tenth. And if you look at that, your tenth is right here. It's the 4. You look at the one behind it, 5 or more, raise the score, 4 or less, let it rest. That's a 2, so you wouldn't change the 4, would you? Okay? Now, number 4. Figure 4 is graphed on the coordinate plane below. Is it true that any sequence of transformations performed on figure 1 will produce an image that is both similar and congruent? Both similar and congruent. Okay, well, let's think about that. Let's think about our transformations. We've got rotations. We've got reflections. We've got translations. Okay. And we've got dilations, right? Okay. Any sequence. If I perform any one of these, will I be guaranteed to get a figure that's both similar and congruent? Congruent means exactly the same. Similar means the same shape, but not the same size. Well, if you did rotation, you'd get congruent and similar. Similar in that their scale factor would be 1, so they'd be congruent. Reflections would give me figures that are similar with a scale factor of 1 and congruent. Translations would give me a figure that's the same size and shape, similar with a scale factor of 1 and congruent. But how about a dilation? What if I dilated this by a scale factor of, let's say, 2? Wouldn't it be twice the size of this original and way over here somewhere? Okay, so it would be similar, but it wouldn't be congruent. It wouldn't be the same size and shape. It would be bigger, right? So is it true that any of those transformations performed would produce an image that's both similar and congruent? No. Why? Because a dilation of greater than 1 of scale factor greater than 1. How about that? Greater than 1 would make a figure that is similar but not congruent, right? Okay. Same for what? Same for a dilation of scale factor between 0, and 1. You know, something like 1/2, 1/3. Any of those would make the figure half the size of what it started as. It wouldn't be the same size, but it would be the same shape. Okay? Then number 5. Triangles DEF and XYZ shown below are similar. Okay, notice they're the same shape, but not the same size. That means they're similar. Triangle XYZ was created by forming two transformations on DEF. Describe a sequence of transformations that could have caused DEF to result in XYZ. Okay, well, first we've got to figure out what we would do first. Let's see. We know they're different sizes, so we've got to dilate DEF, right? Dilate triangle DEF, but we've got to see how much, right? By a scale factor of, well, let's figure out what that scale factor is. Let's find two corresponding sides, because we know that scale factors are equal to the length of an image side over its pre-image, right? So let's see. This bottom piece, this DE corresponds to this ZY, right? Because these have been dilated and translated, okay? This, and this is my pre-image, and this is my image. My image side here is 1, 2, 3 units long. My pre-image side is 1, 2, 3, 4, 5, 6 units long. Okay, so the scale factor is 1/2. This one is 1/2 the size of this one. Each section is 1/2 the size of the other one. The diameter of this one is 1/2 the diameter of this one. Okay? Dilate triangle DEF by a scale factor of 1/2 from the origin. Okay, so let's dilate this by 1/2. Remember, you have got to do the dilation to see where this actually winds up. Otherwise, you're going to wind up not knowing what to do with this next transformation. Point D is at 4, 2. If I dilate that by 1/2, that's going to put D prime at 1/2 of 4 is 2. 1/2 of 2 is 1. It's going to put it at 2, 1. Here's your D prime, okay? F is at 4, -6. Let's dilate that by 1/2. So F prime is at 2, -3. Okay, E. E is at 10, -6. If you dilate that by 1/2, E prime then is at 5, -3. And here's where we would be after we have dilated this by 1/2. Okay, so now we need to figure out what to do next. So you have to do the dilation to see where the figure will be before you start trying any transformations, reflections, rotations, or anything. Okay, now I need to put this D on this X, right? This D prime on top of that X. To do that, I've got to translate up 1, 2, 3, 4, 5, 6, 7. So I'm translating up 7. Let's see how far back, how many left I'm going to go. 1, 2, 3, 4, 5, 6, 7 left. Left 7. Up 7, left 7, right? Okay, so translate, that's the term that we're using here. When we move it over, it is called translate. Don't say move over, say translate. Translate the figure, and you have to tell me where you're translating it and how many. Up 7 units, and what? Left 7 units. Okay, and that maps this one on here. First you dilate it, Then you map it on top of the other one. If they map on top of each other after dilation, they are similar. Okay? And then this final one. Karen designs a t-shirt that has an equilateral triangle. Equilateral triangle. Now, that means all the sides on that triangle are the same length, right? Equilateral, equal sides. All three of the sides are the same length. This triangle has all three sides the same length. The equilateral triangle in her design has a, and I know it says diameter, it should say perimeter of 24. A perimeter equals 24, okay, 24 centimeters. That means if I'm counting around the sides, these three sides are going to add up to 24, okay? She wants to dilate the image by a scale factor of 2.5. What would be the height of her new triangle? Wants to know the height. Okay, height. That's a term you should know from years past. The height of a triangle starts at one tip and goes to the opposite side such that it hits it at a right angle. Okay? Now, when I do that, this side here is divided into two equal pieces. Okay? You're going, how am I going to find the height if I don't know anything, any of these numbers here? Okay? Yeah, I might have a right triangle in here that I could use, which you do. See, right there, you got a right triangle in there that you can use and do Pythagorean Theorem. And here's your height. But how do I get these two sides so I can figure out how to use Pythagorean Theorem, right? Okay, well, let's think about it. It said the perimeter, the distance around was 24. And then we're going to dilate it by a scale factor of 2.5. What would the perimeter be after the dilation? That perimeter would be the original multiplied by its scale factor of 2.5, right? Multiply your perimeter of your original by 2.5, 24 times 2.5. And it tells me that the perimeter of this is 60. If all three sides add up to 60, how do I find the length of just this one? They're all the same, right? Wouldn't I say 60 divided by 3? And if I do that, wouldn't each side be 20? Okay, well, you're going, okay, so this is 20 and that's 20. Oh, no. This blue part isn't 20, is it? This whole thing here is 20. I said this is divided into two equal pieces here. So if this whole thing is 20, wouldn't this piece here be 10? Okay, so now I can use Pythagorean Theorem because I've got the blue right triangle here, don't I? Okay. Let's use Pythagorean Theorem. Now we know from Pythagorean Theorem, when we're trying to find a side length in a right triangle, that a squared plus b squared is equal to c squared, and c is across from the right angle. C is always across from the right angle. Our formula, a squared plus b squared, is equal to c squared, okay? Now, our C is 20. It's across the right angle. Let's substitute that in. Our A and our B, it doesn't matter which is which. I'm going to call the A 10, and that's 10 squared when it's Pythagorean Theorem. There's your height. I'm just going to go in place of B. 10 squared, if you put that in your calculator, 10 times 10 is 100. 100 plus h squared is equal to 20 squared, okay? So in your calculator, let's put in 20 squared, 20 times 20. And what do you get? 400, right? Okay. 100 plus h squared is equal to 400. Now, I need to subtract 100 from both sides because I'm trying to get h by itself, right? And I need to move this 100 to the other side so I can get h by itself. What I do to one side of the equal side, I do to the other. So I've now got h squared is equal to 400 minus 100, which is 300. I'm not looking for h squared, I'm looking for just h, the height of this triangle. The opposite of squaring something is to take the square root of it. What I do to one side of an equal sign, I do to both. H squared, the square root of h squared is h, okay? In your calculator, the square root of 300. That would be second function, square root 300 equals, and you've got 17.3. Okay, let's see what they ask you to round it to. They said, what would be the height of her triangle? Show all work. So they didn't tell me. So we're going to stick with 17.3. Now we need some units to go with this. What units was this in? Centimeters, okay? So your answer should be 17.3 centimeters. Okay, that covers all the questions in this second part in this calculator portion. Okay, go back and check your answers and make sure you understand them.